Okay, we are doing homework problems. This will be Chapter 8, Problem 2. Calculate the densities of Venus and Jupiter. Use the masses and radii given in the appendix. How do these numbers compare with the density of rock and water? There's a note telling us to make sure to convert kilometers to centimeters and kilograms to grams. So, we're calculating the density of Jupiter and Venus. Well, I'm only going to do Jupiter here because we did Venus as part of the class lecture notes. So refer to the lecture notes to see the Venus solution for Jupiter. I have looked up the mass and the radius from the textbook. Of course, if this was an exam problem, you'd be supplied with those numbers. To calculate the density of an object, we calculate the density as the total mass of the object divided by its total volume. Frequently, the density is denoted by the Greek letter rho, kind of a curly P. So if you see that, that typically stands for the density of something. But mass divided by the volume, we've been given the mass of Jupiter. We don't have the volume, but planets are all spherical in shape, and there's a standard geometric formula for the volume of a sphere. That formula looks like that: 4/3 times pi times the radius of the sphere cubed. So we'll use the radius to figure out the volume, and then the mass and the volume to figure out the density. Normally, densities are expressed in units of grams divided by centimeters cubed, or cubic centimeters. So we don't want the mass in kilograms, we want it in grams. So right now I'm going to do that conversion. I'll throw in the right conversion factor. Every 1 kilogram is 1,000 grams. I set up my conversion factor to cancel out the kilograms. That's how I know whether to multiply or divide by the 1,000. And this is 1.90 times 10 to the 30 grams for the mass of Jupiter. Similarly, the volume I want to be in units of centimeters cubed. Centimeters times centimeters times centimeters. That means I want my radius to be in centimeters. So we'll do that conversion in a series of steps. Every 1 kilometer is 1,000 meters. And every 1 centimeter is 0.01 meters. That's what the centi prefix means. And I've been careful to set things up so that the units cancel out except for centimeters. And we get 7,149,200,000 centimeters. Now we can proceed to calculate the volume V. 4 divided by 3 times pi, 3.14, times 7,149,200,000 centimeters, all cubed, both the number and the units. And that came out to 1.53 times 10 to the 30 centimeters cubed. Now the density, this mass divided by the volume, 1.90 times 10 to the 30 grams, divided by 1.53 times 10 to the 30 cubic centimeters, calculates to 1.24 grams per centimeter cubed. So we finished the calculation of the density of Jupiter. Now we need to interpret it. What we learned in class is that different types of materials have standard densities. Gas material tends to be from 0 to 1 grams per centimeter cubed of density. Liquids, like liquid water, are around 1 gram per centimeter cubed. Rock is around 3, and metal about 8. Now, just based on the density, we can guess that Jupiter is mostly liquid, but there's a number of ways you could combine those various materials to come up with this density based on more than just the density. Astronomers believe that Jupiter has a small core made out of rock and metal, very large layers of liquids, hydrogen liquid and water liquid inside of it, and a large gaseous shell, an atmosphere around it. You can't figure all that out just from the density, but the density is part of figuring that out.